Hi, this is Andrea Hendricks. The topic of this video is applications and models of trig functions. Specifically, we're going to look at some right triangle applications, problems dealing with bearings, navigational issues, and also simple harmonic motion. So I've worked some problems from EduSpace and also from the textbook that I want to review with you. The first one is given an angle of elevation from the base to the top of a water slide is 15 degrees. The slide extends horizontally 60 meters. Approximate the height of the water slide. So you've got to think of that in terms of a right triangle that you can draw. So we know the angle of elevation from the base to the top of the water slide is 15 degrees. So I have that marked here. The slide extends horizontally 60 meters, which is represented by our horizontal distance, and we want to approximate the height h. So using the ratio that involves the side h and the side that we know, that is opposite over adjacent, that becomes tangent of 15 degrees is equal to h over 60. So then just multiplying both sides by 60, we get 60 times tan of 15 degrees is equal to h. Use your calculator and make sure that you have the mode in degree mode, and you'll come up to 16.08 meters is the height of the water slide. The second one is another right triangle application. It's saying the sonar of a Navy cruiser detects a submarine that is 4,800 feet from the cruiser. The angle between the water level and the submarine is theta, which is 29 degrees. How deep is the submarine? So you can see in the triangle represented, I've represented the distance between the submarine and the cruiser, which is 4,800 feet. We know the angle is 29 degrees. So now we need to think about what sides do we know based on the angle theta. Well, that is the angle or opposite, which is D, over hypotenuse, which is R. So that involves sine. So we know sine of 29 is D over 4,800. We multiply by 4,800 to both sides to get 4,800. Sine 29 degrees is equal to D. And using our calculator, we can come up with the figure for how deep the submarine is. Number 3 involves trying to figure out a piece of a height where you're given two pieces of information, basically. So you know that from a point that's 95 feet away from a public library, there are angles of elevation. One given is the angle of elevation to the top of the library. The other is the angle of elevation to the top of a flagpole. And we need to find the height of the flagpole. So what I suggest you do is take those two right triangles away from that picture and draw two separate triangles. And we know that the height of the library plus the height of the flagpole is F plus L. That's our total height. So I'm going to represent that as F plus L. And the library's height is just L. So those are our two triangles that we have. And the problem in WebAssign actually takes you through the process that you need to follow. It first says to let F be the height of the flagpole and L be the height of the library, which we've done. Convert the angle 39 degrees 45 minutes into decimal form, and remember we do that by dividing the 45 by 60 to get 39.75 degrees. And then we know that the tangent of 39.75 is the opposite over what? Adjacent, right? So then we can multiply both sides by 95 to get that F plus L is 95 times tangent of 39.75 degrees. Therefore, F plus L is 79 feet. Now we need to find the height of the library so that we can subtract it off to figure out what the height of the flagpole is. Well, the library, we also could use the tangent of 35 is opposite, which is L, over adjacent, which is 95. So we set up that ratio, that tangent of 35 degrees is L over 95. Multiply both sides by 95 to get L is 95 times tangent of 35 degrees. Using the calculator, we find that the library's height is 66.5 feet. So now we know what F plus L is, which is 79. We know what L is, so therefore we can find out what F is. So if we subtract 66.5 from the 79, we figure out the height of the flagpole, which is 12.5 feet. Now, the next one said we want to find the height of a lighthouse, right? No, I'm sorry, not that. The next problem says we want to find the angle of depression from the top of a lighthouse, which is 200 feet above water level, to the waterline of a ship 2.5 miles offshore. So I've put a picture in here. We want to find the angle of depression. So remember, the angle of depression goes from the line of sight down to the object. The ship is 2.5 miles offshore, and we know the height of the lighthouse is 210 feet. So we have a rectangle, or triangle rather, drawn like that. So to figure out what theta is, we need to think about what sides do we know. Well, that is the opposite over adjacent, so 210 over 2.5. But the problem is those are not in the same units, so we have to convert 2.5 miles to feet. So doing that, we multiply by, do you remember? Yeah, there's 5,280 feet in 1 mile. So if we multiply 2.5 by 5,280, we get 13,200 feet. So tangent of theta is 210 over 13,200. Well, to solve for theta, we have to find the angle whose tangent is that, which is tan inverse. So that would be 0.911 degrees. Then simple harmonic motion, you can read more about this in your textbook, but basically it's a way to model an object whose motion is described by movement that is a wave motion and that is periodic in nature. So like a ball, if you bounce a ball and it comes back up and down, it's oscillating back and forth with a wave motion, so you can think of that. You can define simple harmonic motion by A sine omega t or D times A cosine omega t. A means the same thing that it did before when we looked at trig graphs. A is the amplitude, and omega in this case has to do with our period. You remember the period is 2 pi over omega. So if we don't know what the period is, we can set 2 pi over omega equal to that given period and solve for what the value of omega needs to be. The difference here is, when are you going to use sine, when are you going to use cosine? Well, that's determined by its displacement at time 0. If it's at 0 at time 0, then you're going to use sine, because remember the graph of sine goes through 0, 0, right? But if it has a maximum displacement at time 0, so if it starts up and comes down, then you're going to use cosine. So that will determine which of the functions that you use. So in this particular problem, we said we had a displacement at time 0 of 0, the amplitude is 1.6, and the period is 5. So we know the amplitude tells us what A should be, which is 1.5, and 2 pi over omega is going to be set equal to our period, which is 5. So we can solve for omega to get 2 pi over 5 is equal to omega. So we know sine should be used, as we just talked about. So the formula for this one is D is equal to 1.6 times sine of 2 pi over 5t. Find a function that models the simple harmonic motion having the given properties. Here we want to assume that displacement at time 0 is at its maximum. So that tells us that we're going to use cosine. The amplitude is 33, the period is 4. So the amplitude being 33 tells us what A is. Period equaling 4, we can set 2 pi over omega equal to 4. So if we multiply both sides by omega, we would get 2 pi is equal to 4 omega. And then we can divide by 4 to get 2 pi over 4 is omega. Reducing that gives us omega is pi over 2. So just plugging in the value of A and the value of omega gives us our formula that we need. Then I have a note here to work 25, 27, 33, 34, and 39 for the book, because those are not really represented in the web assigned problems at all. So some of these are similar to what we've done before. I just want to go through briefly since I've got it worked out in detail, but I think the key is how to set these things up. So an engineer erects a 75-foot vertical cellular phone tower. Find the angle of elevation to the top of the tower from a point on level ground 95 feet from its base. So here's our tower, which is 75 feet. We're at a point 95 feet from the base of the tower and our angle of elevation. So knowing the angle of elevation would be represented by opposite over adjacent, which is tangent. So tangent of theta is 75 over 95. To find the angle, we need to use tan inverse to get 38.29 degrees is our angle. This one is an interesting problem. It's in the textbook, but I noticed in working this that the back of the book has this answer incorrect because they worked it with a different problem or a different number, so don't get confused that you might think that you got it wrong when actually you got it right. So it says a global positioning system satellite orbits 12,500 miles above Earth's surface. Find the angle of depression from the satellite to the horizon and assume the radius of the Earth is 4,000 miles. Well, the key thing here is that remembering that the angle of depression is the same thing as the angle of elevation. So that would help you think about how to reconstruct the triangle better. And knowing these two angles are the same, we can now go inside this right triangle that's drawn here and think about which sides that we know. So we know the adjacent over hypotenuse. So cosine theta is 4,000 over 12,500. We have to use cosine inverse to get the angle, which is 71.34 degrees. And the one that some of you have questioned is about the bearings. In number 33, says a ship leaves port at noon and has a bearing of south 29 degrees of west. So really the way we read that, this is 29 degrees west of south. So if you think about your compass, west of south is where we're going, 29 degrees. The ship sails at 20 knots. How many nautical miles south and how many nautical miles west will the ship have traveled by 6 p.m.? So a knot is just a way to represent speed in water. It's a nautical mile per hour. So 20 knots means he's really going 20 nautical miles per hour. If we do that for 6 hours, we've got a total of 120 nautical miles. So the ship is traveling out here 120 nautical miles. And we want to figure out how far south and west has he gone. So we're going to just use two trig identities or trig ratios to find that. To find out how far south, we're going to set up cosine of 29 degrees as adjacent over hypotenuse. So S over 120. Solve for S by multiplying by 120 to get 104.95 nautical miles south. To figure out how far west he's gone, we're going to use sine of 29 degrees as W over 120. Multiply both sides by 120 to get 58.18 nautical miles. And for the last problem, it is an observer in a lighthouse 350 feet above sea level observes two ships directly offshore. The angles of depression to the ships are 4 degrees and 6.5 degrees. How far apart are the ships? So you can again take these two triangles apart from this problem and look at what we have here. So we know that the height of the lighthouse is 350 feet. The angle of depression is again the angle of elevation, so think of that. And likewise for the second triangle we have. So what we need to figure out here is this. If we know the distance to one ship and the distance to the other ship, we can subtract to figure out how far apart they are. So to figure out x, we can say tangent of 6.5 degrees is what? opposite over adjacent, which is 350 over x. So tangent of 6.5 degrees is 350 over x. Multiplying by x, we get x times tan of 6.5 degrees is 350. And then we can divide by tangent of 6.5 degrees. So use your calculator to figure out that value. You should get 3071.9. Now, the other triangle that we've taken apart from that bigger picture is the 4-degree angle of depression, which is again the angle of elevation. And the total distance to that ship is the x plus y. So we have tangent of 4 degrees is opposite, which is 350 over x plus y. Well, we know what x is, so we can make the substitution for x. So we get tangent of 4 degrees is 350 over 3071.91 plus y. Multiply both sides through by this denominator. So 3071.91 plus y times tangent of 4 degrees is equal to 350. You can divide both sides by tangent of 4 degrees and leave yourself with just 3071.91 plus y is equal to 5005.23, and then subtract off the 3071.91, and we figure out what the distance between the two ships is, which is about 1933 feet. Okay, I know I ran through those quickly because I had those already worked out, and I've just added some voiceover so you can see my reasoning behind what I did. If you have any questions on any of that, please don't hesitate to contact me. Thanks.